Alright, let's go on to how to graph cardioids. I'm not going to do limosins yet. I'm going to do that next video. But, okay, so to graph cardioids is honestly easier than doing rose curves because it's simpler. That was a terrible sentence. Okay, anyways. So cardioids are in the form of r equals a plus b cosine of theta or sine of theta. So long as the ratio a to b is equal to 1. So they have to be equal. So how do we go about solving these? So let's start with example 1. We have r is equal to 1 plus cosine of theta. So what we really want to know is, does this heart-shaped figure open to the right, open to the left, open down, or open up? And because it's plus cosine, it opens to the right. But if you didn't know that, we can look at it mathematically. When you have cosine, we can evaluate it at 0 and pi to see when r is its greatest, right? So if we say 1 plus cosine of pi, that's 1 plus negative 1, which is 0. So pi, r is 0, the radius is 0. But when it's 1 plus cosine of 0, that's 2. So that means it opens to the right 2 units. So let's go ahead and this. But anyways, you can just figure out that it's positive cosine, so that means it opens to the right. But anyways, so the minimum value. So first, to find the minimum and max value, plug in plus or minus 1 to the function. So we actually okay. So let's find the zeros. This is like the pole. So let's set r equal to 0 and see if the graph touches the origin. See if it's possible. So we have 1 plus cosine of theta equals 0. Cosine of theta equals negative 1. So that means theta equals pi. Okay, so now the last step is axis intercepts. So now let's evaluate r at these values that we have up here. Let me write these down. Theta equals 0, pi over 2, pi, and then 3 pi over 2. Evaluate these 4 values for each function, and this basically gives you the answer. So let's do that. When theta is 0, we have r is equal to 2, so we have 2 comma 0. When theta is pi over 2, you get 1 comma pi over 2. When theta is pi, you get 0 comma pi. And then when theta is pi over 3 pi over 2, you again get 1, 3 pi over 2. Okay. So now let's go ahead and how the heck do we graph this? All right, so this is going to basically be a heart-shaped curve. So there's a 0 at so there's a 0. Okay, so we have 2, 0. So there's a point right here. 1 pi over 2. So we'll say that it's a little bit less higher. 0, pi. And then 1, 3 pi over 2. So it's going to look and I know it's sloppy. I didn't go through this first point. I'm just gonna say that point is right here. We don't care about that point. So this is 2, this is 1, and this is 1 and 2. So there's that one. Now let's do another one. See how it's a lot easier? Let's do r is equal to 1 plus sine theta. Okay, so we know it opens up, but if we didn't know that, we could find the maximum value. Sine of pi over 2 is 1, 1 plus 1 is 2, so pi over 2 it opens up, and when sine is 3 pi over 2, that's negative 1 plus 1 is 0, so that's 0. So it opens up. So now let's find the zeros. 1 plus sine of theta equals 0. Sine of theta equals negative 1. So theta is equal to 3 pi over 2. Okay. So now let's find axis intercepts. So we'll use, again, remember these. We have zero, pi over 2, pi, 3 pi over 2. I don't know why I forgot. Okay. Sine of 0 is 0 plus 1 is 1, so we have 1, 0. Pi over 2 is 1, so we have 2, pi over 2. Pi is 0, 1, pi. And then 3 pi over 2 is negative 1 is 0, 3 pi over 2. And we can graph that. Um, 1, 0 here. It's kind of hard to remember that this isn't Cartesian coordinates, right? It's not 1, 0 where it's 0 is y is axis. In Cartesian or rectangular coordinates. Anyway, so we have 1, 0, 2 pi over 2, so that's a little bit higher here. 1, pi is supposed to be equidistant as this one. 0, pi over, or 0, 3 pi over 2. Right there. So now it goes like this. Perfect. And then now let's do one more. Again, these are very simple. R is equal to 3 minus 3 sine theta. Okay, it's going to open up down. So let's go ahead and solve for 0. So we have 3 is equal to 3 sine theta. Sine theta equals 1. So then we have theta is equal to pi over 2. Now let's find axis intercepts. So it's evaluated at pi, 0, pi over 2, pi, 2 pi. Alright. 3 pi over 2. So when sine is pi over 0, that's 0. So we have 3 comma 0. And then we have pi over 2 is 1. So that's 0 comma pi over 2. And then a pi is 0. So then we have 3 comma pi. And then 3 pi over 2 is negative 1. So we have negative 1 times negative 3 is 3. So that's 6. 3 pi over 2. I did that way too quickly. Let me think about this. Yeah, that's right. Okay, now let's graph this. So 3 comma 0, right here. 6 negative pi over 2, so that's, oh, sorry, 6 pi over 2. So all the way up here. 3 pi, it's like right here. 6, 3 pi over 2, that's all the way down here. I think I messed up somewhere. Okay, at 0, pi over 2. Yeah, that's 0. At pi over 2, sine of pi over 2 is 1. 3 minus 3 times 1 is 0. So pi over 2 is 0. So actually it's like this. This. So then it opens down. Actually looks kind of like a heart. And that'll be enough for this video on cardioids.